this is your Section 3 notes. We're going to be talking about polynomials today. If you ever heard the prefix poly before, you know that that means many or multiple. And we've been dealing with monomials, and that only has one term. That's what that prefix means. So polynomials are going to have many terms, not just one. So we have 3 different learning targets today. The first one, you're going to be able to identify different polynomials, which we're going to get in this very short, quick first section. Then you're going to be able to write polynomials in ascending and descending order. And you're going to be able to add and subtract polynomials. So first things first, we're going to identify different polynomials. So we need to know what the heck different polynomials are. So let's go back to the very beginning with monomials. We did that in our last 2 sections. Monomials only have one term. So an example of a monomial would be 5ab squared c. That is one term, okay? So polynomials, this is what this whole section is about, are many terms, okay? More than one. So all of these terms, you're going to see multiple monomials in one expression, and all of the monomials are going to be separated by addition or subtraction signs. That's how you can tell how many terms are in a polynomial. So there are 2 different polynomials that you're going to see the most, and you're going to have to identify between. So you're going to see monomials, and the 2 different polynomials you're going to see are polynomials with 2 terms and polynomial with 3 terms. If it has 2 terms, think of a bicycle with 2 wheels. It's called a binomial. And then a 3-term polynomial, think of a tricycle with 3 wheels, is a trinomial. So that's basically what you're going to be deciding between when you are identifying these different polynomials. Is it a binomial or a trinomial? Okay? All right. That's the first learning target, easy enough. So the second thing you're going to be asked to do is put these polynomials that you see in order. So one of the things you should be able to see when different polynomials are written out is the degree of the polynomial. So in order to get the degree of a polynomial, you're going to look at all of the exponents and you're going to take the biggest exponent value that you see. Oops. And that's the degree of the polynomial. So just to kind of look down here at these examples, in this example, you have to look at every single term. We have 1, 2, 3 terms. So what kind of polynomial is this? We just talked about it. How would you identify this? This is a trinomial. It's got 3 terms. So let's talk about the degree of this polynomial. You're going to look at every exponent in these terms. So 5x doesn't have an exponent, so it's the same thing as x to the first power, okay? And 4, there's no exponent value, and there's no variable that goes with this term. It's just a number. So it's the same thing as 4 to the first power. So you're going to keep a little 1 here as well. And then we have 3x squared, so 2 is our exponent value here. So if you were to put these in order, if you were to find the degree, you're going to take the biggest exponent value that you see. So the degree of this polynomial is 2, okay? It's the degree of 2. This one here, the biggest exponent value that we see is 7. So this is to the degree of 7. So that's the degree. You won't have to do that very much. I just thought I'd throw in a little tidbit for you, you know, some extra information. All right, but this you will have to do. You're going to have to put them in ascending and descending order. So when you think of ascending, if you're ascending into the sky, you are going up. That's what ascending means. Descending means going down. You're descending down the stairs, okay? So you are going to have to rearrange the terms of a polynomial so that all the powers are x are ordered from smallest to biggest. That's if it's ascending. If I ask you to put them in ascending order, you're going to put the smallest term first based on the exponents or the powers, and then you're going to put the biggest one last, okay? And then if you put it in descending order, you're going to order them from the opposite, biggest to smallest. And remember, it's all based on the exponent. It has nothing to do with the coefficients. You're just looking at the exponents, okay? All right, so let's look at this first example. It wants us to put it in ascending order based on the powers. So ascending means smallest value to the biggest value. I'm going to totally ignore the coefficients. Those have nothing to do with putting them in order. You're just going to look at the exponents. So right now I have 2 first powers. However, this term doesn't have an x value. So anytime you just have a whole number, no x or variable, you're just going to put that first. That's going to be considered the smallest term. So 4 to the first power is going to be very first. That's the smallest term. Then I'm going to look at the terms that have variables and coefficients. So I have 5x to the first, so I'm going to put whatever sign is in front. So it would be plus 5x to the first power. So that's gone, that's gone. All I'm left with is 3x squared. That is my biggest value, so that's going to be last. I'm going to take the sign in front, so plus 3x squared. This is in order, in ascending order, smallest to biggest. Okay? Remember, it has nothing to do with those coefficients. Alrighty? Let's try this one. So we wanted to put it in descending order this time, so we're going to go from biggest to smallest. Remember, based on the exponents. So my biggest value is 4x to the 7th. Okay? That's gone. My next biggest exponent that I see would be plus 10x to the 3rd. It's gone. And then my next biggest is, I'm going to take that sign in front, so minus x squared. It's gone. And then I have both of these are to the first power. So you're going to take, remember, the one that's just a whole number is going to be considered the smallest. So this would be next, so minus 7x to the first. And then, come on, plus 5. Got it? Okay, that's putting it in ascending or descending order. All right, guys, almost done. Last section here is adding and subtracting these polynomials. So I'm going to leave example 3 and 5 for you guys to complete. I'm going to show you example 4 and 6. So the nice thing about 3 and 5 is they're already put in kind of order for you based on like terms. So you guys should be able to solve these after I show you an example of each one. So if you were adding polynomials, you're going to want to find those like terms. So example number 4, you're going to have to match them up yourself, okay, because they're not laid out nicely like example 3 is. So what you're going to want to do is find your like terms in each one of the binomials here. We have 2 terms, and we want to add them together. So I have a negative 3m squared plus 17m squared. So those are my like terms. I'm going to add them together. So when you add negative 3 plus 17, just the coefficients, you're going to get 15, and you're just going to add m to the second power. Remember, your like terms have to be the same variable to the exact same power, okay? Now I'm going to take my other like terms. I just have these whole numbers, so 9 plus 3 is going to give you 12. So you're going to look at the end and make sure you don't have any like terms. These are not like terms. They aren't to the same variable to the same power. So this is your final answer. Okay? You guys are going to try this one on your own, okay? All right. When we get into subtracting, there's an extra step here that you have to be careful of. So you guys are going to try example 5. Let me try example 6. So these are not matched up in like terms yet. So you guys have to find those like terms. So my first set of like terms would be 3m and 2m. So 3m and 2m. So I'm going to be careful because this time I'm subtracting. So you're going to do 3m minus 2m, and that would give you 1m. Okay? Then I'm going to look, I don't have a like term anywhere over here. There's nothing that looks like this. So this is going to be its own thing. I'm just going to bring it down into my expression. So 7n squared comes down. And then I have my whole numbers here. So here's where you need to be very, very careful. We have 5 minus a negative 3. 5 minus a negative 3. If you were to write that out and you saw this, you would automatically know presto chango here. You would add the opposite. So be very careful of your signs. 5 minus and negative 3 is the same thing as 5 plus 3. So that would be 8. Okay? So guys, be super careful with subtracting. You have to be careful of your signs, okay? Because that's where you're going to make your mistakes if you're not careful, okay? There's no like terms here, so there is your final answer. And I'd like you guys to give example 5 a try. All right, thanks for sticking with us. I know there's 3 different learning targets for this section, so hopefully you feel confident with each one. All right.